So today we're talking about titration, and specifically acid-base titration. So when we do an acid-base titration, what we're really trying to do is taking an unknown acid or base, and that's what we're putting in the flask that you see down there, and we're going to use an acid or a base of known concentration in this burette, and we're going to measure how much of that known base or acid it takes to neutralize this unknown acid or base. So we're basically looking for an unknown molarity. Neutralization occurs when the H+ ions in the acid equal the moles of the hydroxide concentration, which comes from the base. So basically the acid neutralizes the base, and they're equal at that point, at which time the indicator that we use will change color. So here you see an example for, here's an acid and a base, and at the point of neutralization, we've created water and an ionic compound, but there's no more separate H+ ions or OH ions. So a couple words we've been using. A burette. Burette is basically just a piece of glassware. It's like a graduated cylinder. It's got very accurate gradations, and it's got a little valve at the bottom which allows you to drip the acid or base, whichever one you know the concentration of, into the receiving flask, which has the unknown. We also talked about indicators. Indicators will indicate when the acid or base has been neutralized. So an indicator will either show that something is acidic or basic, and once it's neutralized, it begins to flip to the other, base or acid. So once again the H+ ions are equal to the OH- ions, the indicator changes color of the solution, and that's when the titration is ended. So we're going to do a practice problem, and here, if you read through the problem, you see we have a specific volume of a known concentration of a base, sodium hydroxide. And we've used that to neutralize 150 milliliters of an acid, but we don't know the concentration of the acid. Okay, and this is how much, once we turned the valve and started dripping base into the acid, this is how much was used. Okay, so we've got a volume and a molarity, we've got another volume, and we're looking for another concentration for this acid. So we'll do that problem now. Okay, so now we're going to solve a titration problem. And if you look at it, it says 38 milliliters of this concentration of sodium hydroxide, that's our base, will completely neutralize 150 milliliters of sulfuric acid. And it's asking for the concentration or the molarity of the sulfuric acid. So real quickly, let's first of all, let's write the neutralization reaction, because we're going to need a balanced reaction for this. So we have sodium hydroxide plus sulfuric acid, right? Both aqueous solutions, and that is going to, if you look at the double replacement, it's going to form sodium sulfate, aqueous, plus water, because neutralization reactions always form water. And if we balance this reaction, we're going to have two of these, 1, 1, and 2. And we're going to need these coefficients when we do the stoichiometry for this. Okay, so we have our first with our balanced reaction. Let's draw a little sketch real quick and see what's actually going on. So we're going to have our burette, and we're going to fill this with what we know, right? And what we know is that we have 0.750 molar NaOH. Okay, and we are titrating that into a container. I'll make it a little flask. We're titrating it into a container that contains sulfuric acid, and it contains 150 milliliters of that sulfuric acid. What we don't know is the concentration. Okay. And so we filled up the burette with our base, and we started the titration. Right? We turned the valve, and as we titrated in, the problem is telling us that it took 38.0 milliliters of this base to neutralize this, right? Change color with the indicator. So at that point, our hydroxide ions and our H plus ions are equal, right? They've canceled each other out. So that's what's going on. We have one volume, one molarity that we know, and then we have another volume, and we have a molarity that we don't know. So we're going to use the molarity equation. We're not going to take any little shortcuts here. We're going to do this the right way. We're going to use the molarity equation, the big M equals moles over liters, and what we know for the base is that 0.750 equals some number of moles over 0.0380 liters. That's how much the volume we used of that base. And we're trying to find the moles because really what matters up here is the moles of each of these. Okay, so that would give us 0.0285 moles of sodium hydroxide. Okay. Now, we are going to use this as the starting point for our stoichiometry. Okay, because this is really just a stoichiometry problem. We're trying to figure out what it takes to completely react. So we're going to start with that number of moles of base. We're just going to do a one-step stoich to get the moles of acid. So again, if we look at the coefficients, 2 moles of NaOH is neutralized by 1 mole of sulfuric acid. Notice that this is a diprotic acid, right? It's got, when this dissociates, it's going to give you 2 H pluses and a sulfate ion. So it's what we call diprotic. All right, so if we do that, that comes out to 0.01425 moles of sulfuric acid. Okay. Now that is not your answer. That's just telling you how many moles of H2SO4 were in this flask. So we want to find the concentration. So once again, we go back to the molarity equation. And now we know the moles of H2SO4. Let me bring this up a little bit. We know the moles of H2SO4 is 0.01425 moles. And we know that the volume was 150 milliliters, or 0.150 liters. Right? So again, we're doing moles over liters to give us the concentration. And that comes out to 0.050 moles per liter, or big M. So not quite 0.1 molar. And that is your answer for the concentration of the acid. Okay, so balanced equation, molarity equation to find the moles of what you know, in this case the base. One-step stoich to find the moles of what you don't know, and then the molarity equation again to find the concentration of what you didn't know. That's it.